Could you give a sense on, how the aircraft and engine manufacturing has kind of, changed over a couple of decades?
The way the industry has moved is significant. In my mind, there is no one single silver bullet that we should do this and not this. We are on the journey of maturing these technologies. AI is helping us design a maintenance plan for every engine based on where the engine performs.
What kind of skills will we need in flight engineering? Is it changing because of this advent of AI?
The inspection technology, AI technology together does magic. Hopefully, that was
Right.
interesting for you.
Hello and welcome to The Interface, the Hindus podcast to make sense of the accelerating pace of change underpinned by technology. I'm your host, John Xavier, the Hindus technology editor. In today's episode, we are joined by Alok Nanda of GE Aerospace, and this is going to be an interesting conversation. So I'll give you a very brief intro on what this could be about. So the aerospace industry is witnessing a convergence of advanced technologies, urgent sustainable imperatives, and shifting global dynamics. How will AI and other innovations transform aircrafts and engines and the broader transportation ecosystem? This is the broader and the larger question that I will be exploring with Alok Nanda, CTO, GE Aerospace India, and CEO of GE India Technology Center. Alok is also the co-chairperson of the Confederation of Indian Industries. He's on the National Committee on R&D and Innovation. Alok, welcome to the interface. Thanks for making the time.
Thanks, John. Looking forward to it.
Great. So, Alok, for the sake of our audience, could you give an overall sense on what happens at the GE Technology Center in Bangalore and also your broader role in the GE Aerospace leadership?
Sure. So, as you know, the GE Technology Center in Bangalore is a co-located site for several of the erstwhile GE businesses, with GE Aerospace owning the site after we became a standalone GE Aerospace company. So what we do in GE Aerospace is essentially we have three types of teams. One is the engineering team, which looks at the development of our engines for today, tomorrow, and future. We have a research team which looks at primarily for solutions which are out there, the technologies that we have to mature so that they can be integrated in our products of the future. And then we have digital technologies teams which enable digital processes which enable us to work more efficiently. So those are the three types of teams we have. Our engineering and research teams are very much engaged in development of aerospace technologies, as I said, for today, tomorrow, and future. And if you think about the engineering team, you can divide it into two parts. One is more focused on works with the research team, more focused on developing technologies for tomorrow. And the second half of the team is more focused on our fleets of today, supporting the customers, supporting the MRO shops, and supporting our suppliers. So making sure that our customers get the best out of our products. So that's the part. That's the job of our fleet team. So overall, that's what we do for G Aerospace in our center.
And your role at the GE Aerospace as the CTO.
So I am the site leader, and I'm also as you mentioned, the CTO for G Aerospace teams in India. So I lead the aerospace part of the teams and also manage the site.
Right. And you're also a sort of a GE veteran, and you've been there for quite a while. So, given your role prior to this with DRDO and then with GE, could you give a sense on, how the aircraft and engine manufacturing has kind of, changed over the last couple of decades? Just give a kind of a sketch on, how things have moved.
Yeah, so as you said, this is my 24th year in GE, and I started off as a researcher, and then worked a bit of my time in the energy part of the GE business at that time. And then since 2012, have been part of the aerospace business. The way the industry has moved is significant. If you think about what has remained constant is this our purpose. Like we say that we invent the future of flight, we lift people up, and we bring them home safely. So bringing people home safely, safety has stayed constant. So that for our industry is like really critical because it's we work on the trust of our customers. So when you get into an aircraft, you don't really think about an engine and whether it will work or not. You're thinking about, okay, where you need to go and all. And that we take very seriously. The safety has been constant. What has changed is how we have been designing engines. So the more and more usage of high performance computing, as the HPCs, the high performing computing infrastructure has evolved. Now we were using CPUs, now we are into very much into GPUs. What has that has enabled is that we are able to explore the design space much more granular in a granular manner. Now, if you have a more computing power and you can do it faster, you are able to optimize and you are able to explore the design space in a much more efficient manner and much more faster. So that has really evolved. Like we are like really pushing the boundary of durability, of efficiency in a manner that I had not really visualized before. That could happen. Like our pre-test predictions have become better. That means the design cycle times have become shorter. The physics continues to be very complicated, but we are able to understand the physics a little bit deeper. And then we are able to explore things which we were earlier not hesitating to do. As an example, during COVID, when people were thinking whether people will fly or not, we went ahead and announced our RISE platform, which is a revolutionary innovation in sustainable engines. And normally, what we've seen in the past is that when one engine replaces the previous engine, it's almost a 20%, it's almost a 10% efficiency gain, traditionally, over last 3 or 4 decades. This time, when we announced the engine, we announced a 20% increase in efficiency, which is like a step change. And for all the reasons that I described, we are able to think in that direction. Then we also announced some revolutionary technologies like using of open fan. Now, open fan as a concept has been there before, but it produces a lot of noise. So now how do you reduce noise? That is where all this computational power comes in, physics comes in, understanding of physics comes in, and exploring design space comes in. So then we also announced, okay, we will introduce hybrid electric in the same engine. We'll make this engine hydrogen compatible. We demonstrated sustainable aviation fuels in our current engine. So that the fact that we can go there with that assuredness is the change that I see. So the safety and the focus on safety remains the constant. The change is how we deploy technology these days with all this computational power in our hands to be able to explore the design space more granular manner. That has changed dramatically, and that's something that we are trying to utilize in our engines of the future as much as we can.
Right. Yeah, that's interesting. Just want to get drill down a little deeper and then just see, what are the advances in material sciences that, was making these things happen? Could you give a sense on how that landscape is?
So in some sense, we call ourselves a materials company, right? Because the if you think about it, the temperatures inside the engine are higher than melting points of most known metals. Okay, all known metals, the temperatures are more. So you have to balance the heat. You have to use the right materials so that you can get them the life so that it's economically viable. Okay, so it's a lot to do with material science, aviation technology. And I'll give you one example. So we've been developing alloys, specialty alloys for quite a while now, but they have like at after a point you hit a sort of a barrier, okay, then that you need to cross somehow, but you require a completely different technology. So what we introduced in some of our engines are something we call CMCs, ceramic matrix composites, where the matrix is also composite and the fibers are also composite. And we've developed a technology where now not only do we get the temperature resistance of ceramics, which is obvious, but we also get toughness, which is not so obvious with ceramics. So the ceramics that we use in our home, if you like hit them or they drop, like they just shatter. They're not tough materials, but that we can't afford putting into an aircraft engine. So how do you get toughness while you also get the temperature resistance has been something that we've like worked on for last 2 decades, and now these CMCs have found a way into our engines. We had a few of the CMC components in LEAP. We now have a lot more of them in our latest engine, which will power the 777X for Boeing, which is G9X. There it will have a lot more CMC content, and in future we expect that the CMC content in engines will increase. So that's an example of how material development happens. Another example is additive manufacturing, right? So now that we can to be able to optimize at a system level, if you could get performance and if you could cost together, if you can get performance and cost together, that's the holy grail, right? So it's something that every engineer is trying to reach at. And additive manufacturing then allows us in certain domains, in certain areas, in certain like component for some components to get performance and cost together. And so introducing additive manufacturing, it's not it's enabled by materials because essentially that's what you need to unlock to be able to deploy it again in economically feasible manner. So those are some examples that will give you an insight into how we think of material science.
Right. You mentioned about the open fan technology, that was in the past and then it's coming back. How different is it going to be in this specific time, right? Because it's been out there for some time. So what kind of changes are going to happen that will make it into the advanced aircraft of our generation?
So there are two very specific things that we need to think about when we think about open fan. The advantages are obvious. You see when you enclose the fan, like anytime you see an engine, you see when you enter an aircraft, you see towards the engine fan, it's enclosed in a, let's say, a duct. That's the traditional way, a ducted fan. That's called ducted fan. And now what we are trying to do is, okay, remove the duct. What does that do? It removes the frictional losses, and hence you become much more efficient. But what is the problem with the unducted fan? Why it has not been in vogue for engines? Twofold. One, they produce a lot of noise. So if you've been near a wind farm anytime, you would have heard how much noise. So it's when the blade comes and cuts the like it keeps cutting. It's very noisy. Now, you don't want your passengers in the cabin, or you don't want the cities to experience that noise as when the aircraft moves, goes up in the air or comes down, or you want the passenger in the cabin to not always have this kind to deal with this kind of a noise. Okay. So that's why they were not getting introduced. The other thing was, okay, what happens if the blade breaks? Okay, and where will it go and hit? If it is ducted, it is contained. If it's unducted, it has that challenge. Okay. So we are working towards solving both these challenges. And we've made like several breakthroughs in last 2, 3 years where we've got the noise levels that we are very happy about. We also have strategies to get to safety standards that are expected from an engine. And so those were the challenges that needed to be solved before that technology could be introduced in a commercial engine.
Right. And also talking about fueling these engines, how do you think, or what would be the future of the flight, like in terms of, will it be completely the airline fuel base? It's not going to change, or will we expect something hybrid, or is it possible to think of electric at all? What's your sort of point of view into the future from him?
Yeah, in my mind, it's not a silver bullet. It's not one silver bullet. It's probably a combination of many things that will make our flight more sustainable. That's why I said when we launched the Rise platform, we actually did not launch it as an engine. That this is the engine we are going to develop. We launched the platform. What it means is that we said that okay, with this platform, we will mature many technologies. And based on the maturity level and what the customer and the environment expects, we will introduce those technologies. And we will mature these technologies in a manner that we have validated results. It's not an anecdotal, like emotional information. It's more of an objective assessment of which technology gets us what. So I talked about a few things. Like we talked about an open fan that essentially makes it more efficient. You get 20% more efficiency, so you burn 20% less fuel. So that's one way of doing it. Another way of doing it is I talked about hybrid electric. Now, if you can introduce some elements of electric in a commercial engine, you get like some percentage points of efficiency gain. Again, you burn lesser fuel. Then there is this always this talk about hydrogen. Hydrogen as a fuel is awesome because it doesn't produce that much like it's not that harmful for the environment. It has its own challenges like contrails and all, but we have to solve those challenges. But hydrogen is very light. Imagine like if it's nine
So it
times lighter.
carries the aircraft carries lesser weight of fuel.
No, imagine if you have to fly at the same distance. Okay, so it's it has a lot more energy, which is good, but it's a lot more lighter also. Now, if you have to store hydrogen inside a fuselage, imagine the size of the fuselage, and you can then say that okay, no, I'll store it in a liquefied form. But then you have to put a full lot of refrigeration system to actually store it in a liquefied form. So there are a lot of challenges. It's not doable. It's just that which technology you mature and what is the maturity level of the technology you deploy. We are also talking about fuel cells. So what it means is that you like use hydrogen, like you really generate the fuel as you are moving, and but then you have a chemical plant flying along with you, and so how do you create the sense of safety and actually the reality of that? So hydrogen will be very much in contention. So we are working with Airbus, our partner, and we have a plan to demonstrate 100% hydrogen flight in with one of our engines in partnership with Airbus in next like 5 to 6 years. So that's another fuel option. Another fuel option is what is called sustainable aviation fuel. That is very interesting. If you think about it, now what our interest is that we should not add more carbon to the environment. So the carbon that already exists in the environment, if you use that to create fuel, then you stay carbon neutral. So, for example, if there is a tree and it decays, it dies, it releases carbon. So that carbon is already there in the tree. It is already there in the environment. So if we can create a fuel, not introducing new carbon from under the earth, but using only those resources which are above the earth's surface, which are already in the environment, which will get into the environment someday anyway, then that fuel is called sustainable aviation fuel. That fuel has almost similar properties like our aviation fuel. So it's you can have a drop-in kind of an environment where the engine stays the same, the aircraft stays the same, the airport stays the same. You just change the fuel and it works. But it needs a supply chain for that kind of fuel. So these are some of the technologies which are emerging, which will in future give us more sustainable flight. And as I said, like there is, in my mind, there is no one single silver bullet that we should do this and not this. I think right now we are on the journey of maturing these technologies. And once these technologies mature, in which configuration we introduce, which technology will be dependent on the economic viability, what the customers really need, what are some of the environmental challenges they solve. I think all those will determine which what goes where. You also asked a question of fully electric. I mean, yeah, it is possible, but right now with the battery technology we have, it's for shorter distance, very small aircraft. It's not imaginable that you'll have a fully electric, say, A320 or 737 kind of an aircraft. Like that, then you can only carry batteries, you won't have passengers.
Yeah.
Right. So a lot of technology development needs to happen before we get there. And hence, what we are maturing is the hybrid electric. So you reduce the consumption of fuel by introducing some electric elements similar to like hybrid cars. The concept is similar. The challenges are a lot more because this has to fly. Okay, so weight becomes a big deal for an aircraft.
Right.
Energy density is a very big deal for an aircraft. So it's like almost reducing the energy density by several orders of magnitude before we can really get a hybrid electric system which is economically viable.
I think from what you say, the thing that be very interesting to look forward to is the Airbus thing that coming out in the next 6, 7 years, maybe with the hydrogen fuel powered aircraft engine.
Yeah, so that's a
Possibly
test
that'll have
bed.
very different architecture, right?
Yeah, that's the test bed. So that will just be for proof of concept of the technology.
Right.
We are far away for commercializing it. That's the test bed that
Oh,
we have planned to fly.
right. So I think these are more like into the future, and the other things that are more urgent, and a lot of people are deploying now, which is more like an elephant in the room, is AI. So I'm sure that
Yeah.
aviation and aerospace is also doing its own thing with AI. So what's happening at G Aerospace in terms of AI, both in terms of maybe engine design and also in terms of aircraft maintenance? If you could give a sense on that landscape.
Yeah, we are exploring AI development and we are deploying AI in many areas, but I'll limit our discussion to when it comes to aircraft engine maintenance. Okay, because there are other areas like supply chain efficiencies and financial efficiency, many other things we are deploying AI. But about what I will talk for the context of this podcast is what we are doing for the engine side. Now think about an engine, the same engine which is flying in two different environments. Same configuration engine, same aircraft flying in North America, Western Europe, and same aircraft, same engine flying in, say, Middle East, India. The amount of dust and sand in one environment, the temperature profile in environment with respect to the other environment are very different. Now, if you have same maintenance principles for both these engines, you will either lose life on the table that you won't use the engine very effectively, you will remove it faster, or you will have a danger of, okay, you can't plan the removal, the engine will have to be removed without planning because you didn't anticipate it and because the environment was much more severe. So AI is helping us design a maintenance plan for every engine based on where the engine performs. So what we do is we collect the data. So we have all the data anyway. We had the data, but we are using the data to see how the engine has been used. And we correlate that with how the engine performs. And then we decide the maintenance intervals. Now, what we've seen is that because the physics is complicated, we sometimes not only need the parameters of the data, like which are like digital, look at the temperature or this and that. Sometimes we also need photos. So what happens is, suppose an aircraft lands, it goes to the hangar. Suppose we have those boroscope. Boroscope means the hole. There are holes in the casing from which you can insert a camera, flexible. a camera, and you can take pictures of what is going on inside. And those pictures tell us a very nice story because they tell us, okay, what we could expect in next 100 cycles, in next like 200 cycles, next 50 cycles. And based on that data, all this data combined, what the engineer has to predict using AI is when the engine should get removed. Because the airlines would want to fly it as long as they can. We would want the airlines to fly it as long as they can, but we don't want to put like either the airline schedule at risk or any other. We don't want to introduce any other risk. So we don't want to delay it too much, but we also don't want to accelerate it too much. And that's where the AI has found a brilliant use. We call it analytics based maintenance. We actually deployed it with one of our customers in Middle East for one of our wide body engines. Like I think about 7, 8 years back, and it's performed really well. That customer in their like they have a annual magazine. In one of those issues, they described how much this has meant for them because not only have they can they plan better. It's very disruptive when an aircraft suddenly becomes unavailable. You planned the whole lot of trips and all that. Secondly, they've also like being able to be more effective in how many time on wing. We call there is a metric called time on wing, how much time the engine stays on wing, because that's the only useful thing, right? So that also increased their maintenance schedules also got much more predictable. So they were really happy with that. Now we've taken that learning and now scaled our analytics based maintenance product to other engines as well. And so now we have several customers around the world on this using AI to make decisions based on data. Now, one of the things which people don't realize is that an AI is as good as the data that you feed in. Now, if you have a consumer portal, you get a lot of data, right? And so you have so much data. Now, if you have an engine, how much data do you have? It's not much. Right? You don't really want too many failures. So, I mean, so to say that this is a good engine, this is a bad engine, some bad thing should happen. And our job is to reduce that. So, in some sense, what the challenges that we face is that how can we get as much data as we can? And so, if it's a video data, if it's a picture data, it's very also expensive and difficult for customers to send it to us. It is also like if there is a flexible camera will essentially see every time a different image. And so automating that is very difficult. To solve all these problems, what our inspection team did, the research team that works in Bangalore, what they did is they created a tool called what is we call as a blade inspection tool, which is like in some sense it goes and attaches itself to the borescope holes and every time gives a consistent standard image. Now with that, we can once we get the standard images, it's easier to automate and easier to scale. And that has been the real breakthrough for us to scale our analytics based maintenance product. So the inspection technology, AI technology together like does magic because otherwise you don't get the quality of data and you can't really like then automate it to be able to scale it to the customers all over the world.
So that's interesting. Alok, I think one particular point I want to pick up from that interesting segment was you said you deployed that 7 years ago, which was like pre-generative AI phase. So that's something new, and having an analytics maintenance at that time would be very different from what is happening right now. How do you see this difference, like between deployment in the previous time of pre-generative AI and now?
Yeah, a lot has improved. Like our ability to scale has improved. It was just one customer, one engine. They were facing the some issues, and we thought this would give us and the customer a benefit, so we did that. It was almost experimental at that time, but the success has been so much that we've now deployed it to several engines, several customers, several regions. Algorithms have improved, our computational power has improved, our ability to send data has improved. We use a lot more data than we could earlier. So our ability to predict has improved. So I would say it's been like a journey. But if we had not started at that time and created a proof point with the customer, I don't know if we would been able to take so many steps over
Right.
the years to get to where we are today.
Right. So in that line, so what's the horizon like for the next 3 to 5 years? G Aerospace in India and the technology center. What's your plan? One is of course the experimentation on multiple different ways in which you can power the engine is happening, and the open fan technology is becoming another area that you're working on. How do you think the other areas, like for instance, the China plus one, where people are looking at manufacturing differently in the new Trump regime? So how are these things going to play into the way the India Technology Center works alongside the the broader global company?
Yeah, I'll take you slightly back in time just to set the right context. Like
Right.
till about a few years back, we were mostly doing science, physics, doing design work and all that. And suddenly we found ourselves, our center, right in the middle of the most highly accelerated growth region in the world. If you think about only India, now I'm talking about like the rest of Southeast Asia also. But if you think only India, we have like 1,300 engines. Today, we are 2,000 more on order. It's completely dramatically different. The MRO shops in our region are like really growing dramatically. We do manufacturing in our Pune manufacturing shop in India, but we also signed a deal, almost $1 billion deal with Tata's to do LEAP-1A components last year. Okay, so we suddenly found our team right in the middle of this very rapidly growing region. And responsiveness to the customer, responsiveness to our shops, responsiveness to suppliers, all those things were really, really critical need for the business at that time. So we transitioned ourselves to not only be the best with physics and sciences design work, we also started on our journey of services technologies. That is where this ABM thing actually started because the customer wanted something and we were right there. We then stepped in and did something. We did a similar thing with our Malaysia MRO shop. It wasn't like performing at that moment, like those many years ago, at the level at which the business was expecting. We were right there in the same time zone, similar culture. We helped that shop grow. When the Tatas started their plant in Hyderabad, so we worked with Masood, who was the leader of that entity at that time, and I remember a dialogue with him. He said that, okay, Alok, like we have to make this successful. And I said, yeah, we have to make this successful. We created a team for him which supported them to then get to the quality and the delivery levels that an aerospace, a G aerospace shop really demands. We help them with that. Now we are introducing some of the new technologies in Pune, and hence same way the team is helping. So I think why I gave you this context is that our work scope has evolved to take into account the needs for our business in this region and especially in our country. Our like supply chain is definitely going to grow. You mentioned some of the geopolitical things, but even if you keep them aside, if you think about it, like we have 44,000 commercial engines today. In next like decade, we will get to like more than 65,000 commercial engines. It's dramatically evolving. Just to give you a data point, which will make tell you how real this acceleration in India is. If you think about North America, there are about like 350, 400 million people, and for every million people, there are like 8, 9 aircrafts. For India, we have like in the next decade, we'll have like about 400 million and middle class people who can really afford to fly also. And we will have less than one aircraft per million people. So the growth is bound to happen, and it's going to be dramatic. And so the supply chain has to evolve, and that's where I think our team will play and is playing a critical role in making sure that the shops in our region are well supported and create the quality and credibility. Then more work flows into those shops, and we can support our customers in the region and support the whole world from this growth in supply chain in our region.
Right. When you talk about the horizon, in terms of all the activity that's happening, it's increasing. Also, one of the things I wanted to touch upon is the supply chain issue, which is actually delaying your delivery to HAL. So, is this like a change in the supply chain activity that's happening, or is it because of the pandemic-related delay that's actually causing the delay in terms of delivery?
So we are working with HAL, we are working with our suppliers to remove these constraints. So you're right. I mean, pandemic did cause the suppliers to scale down, and the scaling up has not been as efficient and as fast as we would have expected. The volume has grown, and the scale back has been a little bit slow. That's what is causing most of the supply chain issues. But we are working with both HAL and suppliers to see what best we can do.
Right. And the this whole strategy, how does the talent come into this whole picture? Like, what will be the composition of talent in GE's growth in India, and also what kind of skills will we need in flight engineering? Is it changing because of this advent of AI? What's the dynamic there?
Yeah, talent is like continues to be the top like thing that we like focus on, because without talent you can't really get the growth. We announced last year hiring about 800, 900 people around the world, and a lot of that growth also happened in India. It's so there are, if you think about the talent progression, or you asked, okay, what different type of talent would be required moving forward. I think what is a given is that the ease of comfort of deploying AI into anything and everything responsibly. We are a very regulated industry. We have every product that we fly is certified to be flied by an external agency for right reasons, for safety and everything. And so it's our responsibility that when we introduce new things like AI, we like do it responsibly. We do it in a manner that can get certified and does not introduce some other inadvertent biases or flaws which become a problem later. So from talent perspective, like being comfortable with digital technologies is like is a given. And these days the people that we get, what we are not worried about their digital acumen. What we are more worried about is, do they know the fundamental engineering skills still? Okay, and that for our kind of business, which is like aircraft engine is one of the most complex products man has ever designed and produced. Knowing the fundamentals stays the top priority for us. We can teach digital, that the basic gas turbine technology teaching is that's the challenge for us. So what we do, like one of the things that we celebrate, we had two very good celebrations this year. One of the celebrations was around, we completed 25 years of engineering in India this year. We started in 1999, it's to 2024. So, and we had several people who completed 25 years. We recognized them. That was the celebration. So that we like our track record has been pretty good at retaining people. But if you think about the other milestone that we achieved this year was 20 years of our Edison program. So what we do is when we get any engineer into our workforce, it's a 2 to 3 year program that we do with them, where we reintroduce fundamental sciences to them, but in an applied manner. So what they do for these 2 to 3 years is, one, they rotate in different teams, learn on the job, but we also do coursework with them where those fundamentals we reintroduce, but we have them do a project or an assignment for every fundamental. So it's a very applied fundamental engineering knowledge that this program offers to them, amongst many other things. So this is actually a 100-year-old program. Like it's almost 100 years. In India, this has completed 20 years. And that's our way of actually getting the talent to be where we really want it to be. So in my mind, the digital is not the challenge. Every kid these days comes with like the acumen, digital acumen of almost everyone we hire is like higher than some of us who've been there. So that's not the challenge. In my mind, the challenge is can we still get the basic fundamental sciences to be strong, and that's something that we focus on quite a bit.
That's interesting. I mean, very interesting perspective. And is there something that you can share in terms of how you're seeing this happening also from your role as co-chairperson in CII? This skill, because a lot of people speak about digital skill and AI and all that, but the fundamentals is something that a lot of people seem to be missing out. So, is there any kind of a measure or something that we have through which we can identify, how important is this development of foundational and fundamental science skills?
Yeah, so I'm co-chairperson of the R&D committee for CII, and innovation has been one of our key drivers. So if you see innovation in India, we sometimes confuse it with invention. So in the definition of innovation, in my mind, is innovation is equal to invention multiplied by the value that it produces. So you discover something new, but it's innovation if it has some use, either to the society or commercially or in any way, but it has to have some use. So innovation, if you see in India, we are on a journey, we are doing much better than what we were doing like a few years ago. But if you compare our innovation index with several other uh, countries that we would be proud to compare ourselves with, you will see that there is still a journey that we need to be on. And I think that's where the basic understanding of the need of the market is, or the need of the product is, where the fundamentals come into play. So you can only create value if you understand what value you need to create. Okay, what is it that the customer needs, or what is it that the customer would benefit from, or the society would benefit from. So our effort has been, even in CII, to explain to people, like for example, what we introduced this year is, we have a TRL level. So a technology graduates through TRL levels before it can get introduced to the customer around TRL 9. TRL 9 is when it is like being used commercial. I mean, when it is industrialized and it is being used. So TRL 1 to TRL 9 is a progression that we take. What we discovered is that everybody uses a TRL, but nobody really, there is no standard. So when government incentivize innovation, or incentivize growth of some of our scientific labs, they measure them on TRL. But if the TRL measure is not standard or consistent, then we don't know what we are measuring ourselves on. So that's one of the examples of what we tried to introduce through CII this year, and several other things. So we are trying to get people to understand that fundamentals are like the ones which takes us forward. And digital, we are good anyway. And I'm not underplaying the importance of digital, and it's really critical for our economy. But if we really want to get into the product space and the industrial products, and we want to be the front runners, or we want to be the ones who invent those things, then we can't, like, we have to emphasize on fundamentals as much as we emphasize on digital today. So that's been my view. That's what I've been trying to do with the CII forum as well.
Great.
By the way, for our team in Bangalore, we have like more than 1,000 patents now.
Oh,
So we've been like really high on innovation, and
and
it's
so
one
that
of the higher performing teams across the world.
right. And does this change the recruiting style or method for research development areas like yourself, or is this something that you feel that we've been doing this for about the last 2, 3 decades, so we are good as it is with our testing method when it comes to recruitment? Has this particular shift in between digital and the foundational sciences, is that changing the way that you're measuring people, or the way you measure people who come in?
So, two different questions. One is how we recruit. We do recruit on fundamentals. As I told, teaching digital is when you have fundamental skills is slightly easier than teaching fundamentals when you
Absolutely.
don't have them. So that's something. So hiring stays like that. Evaluation. So what we've also been very conscious of is that, like, what is the purpose? So is it problem solving for for, like, is it technology for the sake of technology, or is it technology for the sake of problem solving? So I have this, when I talk to my teams, I talk to them like this ninth grade physics, okay, distance and displacement. What we want is displacement. What we keep measuring is distance. Okay, you walked quite a bit, but you didn't move right in the direction where you need to go. So is it technology for the sake of technology, or are you getting any benefit from the technology? So our measurement systems are like incentivizing people to deploy technology to gain either productivity or better assessment of design space or some other outcome which is beneficial to our customers, to our society, to our environment. So I think that's a big change or big difference that I see when I see within G and when I see some of the other organizations that I've heard talking about it. We've been very focused on okay technology for outcomes, not technology for the sake of technology.
Right. Great. Thank you so much. That's very insightful. And thank you so much, Alok, for taking out the time to share all that we have to know about aerospace in general, what's happening in fuel technology, what's happening within the engine itself, and how AI is being used. It's been great talking to you. Thanks for making the time.
Thanks, John. I enjoyed the discussion as well. Thank you for organizing this.
You're welcome.
Thank you for tuning in to the Interface podcast. For more such episodes on technology and innovation, tune in to the Interface on Spotify, Apple Podcasts, or wherever you get your podcasts from. Do share your comments with us at the interface at thehindu.co.in. To keep yourself updated with the latest tech, please go to thehindu.com or follow us on all social media platforms. Thank you.